So, hi everybody. My name is Josh Feingold. I'm the lead solutions engineer for Tom Sawyer Software, and I'm going to be telling you a little bit about gaining insights through visualization and analysis of graphs. So obviously we're all here because we're interested in graphs, and this is kind of, I'm going to tell you about what you can do once you have the data and you want to look at it and figure stuff out from it. Right, so Tom Sawyer Software, just to give you a little background, is a leading provider for the building of graph visualization and analysis applications. We do everything end-to-end related to data and creating visualizations. We have offices throughout the world, and we've been doing this since 1992, so we are by no means new kids on the block in this space. So the problem, fundamentally, that probably if you're in this room you're dealing with in some capacity, is that you have data. Data has relationships. Sometimes entities or relationships occur at locations or associated with locations. Sometimes, I mean, usually relationships are pegged in time. Sometimes entities are pegged in time. And you have these cross-sections of all of these things and trying to figure out what is the best approach. And so you've got data sources, which represent your database. You've got a data model, which is sort of the subset of your data that you want to work with, and a data view, which is what you're actually going to look at. And that's sort of where we come in. So a data view might look something like this. So there's a database on the back end here. It is composed of 1,000 incidents that were released by the Seattle Police Department that were criminal incidents. And because the Seattle Police Department doesn't like to tell you who was involved in all these incidents, we made up some people to be associated with them. But from working with real police and intelligence departments, this is kind of what real networks look like. So we added in some fictional folks here, and we created a network of people and incidents that you can see up here, and you can see relationships between people, and you can see there's a nice timeline, and there's tables. So data is not always just one thing. And so we're going to talk a little bit about how to sort of decompose your data into the right bits and pieces to actually make it useful to you, and how you can see it when you do. So Tom Sawyer sells a product called Tom Sawyer Perspectives. We're going to use that as the basis for the demonstration today, but these ideas are generalizable. We are able to connect to a wide variety of data sources on the back end. Obviously, Neo4j is one of them. We like working with Cypher. It makes us look really good when you can run a query on 100 million nodes and get back exactly what you want really fast and then draw it. So we love working with Neo, but we also do have the ability to connect to other things, and in fact, Cypher lets you query into other things as well. So Neo4j and Tom Sawyer, we make pretty convenient pair to work together. We create a whole variety of views that I sort of flew you through very quickly, but these include timelines, drawings, maps, charts, tables, trees, and details inspectors. We're really specialists in the graph layout space. So graph layout means taking all of the stuff that you pull up in the Neo browser and turns into those little bobbing balls and the lines between them, and actually arraying them out in a way that looks really nice and helps you access the aspects of your data that you need to access. And if you go show if you go show your boss 5 bubbles in a Neo browser, they're not going to be as able to understand that you can turn this into a final application as if you show them 5,000 nodes that have all been laid out in a perfectly arranged orthogonal schematic with no overlaps and clean labeling and customizable UIs that have exactly the iconography that he's familiar with and has all the labels and all the interesting alarms associated with them, and just decorated the way that feels familiar. So generally we have 4 archetypes of layout, all of which can be constrained and customized and parameterized to meet your needs. So we have circular, which shows groupings of stuff. We have hierarchical, which is what it sounds like. It shows hierarchies, of companies or of flow of data or of process flows, orthogonal schematics, which are great if you want to pack in a lot of information into a small space, and you want to make sure that none of it sits on top of any of the other bits. And symmetric layout, which is sort of like your traditional view of a network layout. Probably many of you are familiar with force-directed layouts. That's what the Neo4j browser uses. This is sort of in that same family, but it's a bit more advanced than that. And so we also provide graph analysis. So depending on what type of analysis you're interested in, we can show you how that works. And we have a whole variety of them. And really where Tom Sawyer perspectives gets interesting is that we provide a graphical designer that allows you to go very rapidly from, you've got your Neo4j database over here, you want to supplement that with some Excel source, and then you've got another database that's created by another department who isn't quite as forward-thinking as you are, right? And they're still on their legacy database that's maybe got a SQL data store, or they've got something new that they've just implemented, and they've got a RESTful interface on it, and you want to use those RESTful queries, and you want to federate all that data together, right? And then you want to say, okay, what does my data look like together? How do I want to make those nodes and edges look? How do I want to create that as a table? How do I want to add a geographical map to that? And we can do that all from a configuration step. And so this is for the project that I showed you before. All right, so for this particular application, we have a configuration that says, hey, I want to create a network of people and incidents, or a network of people and their connections to other people, or a Google Maps view that shows me, Seattle and where all of these incidents occurred. And to go along with that, I want these filter controls and these settings, and I want to see a chart down here that shows me the different types of assaults that have occurred. And so, if you've got a graph, or you've got something that isn't quite a graph yet, you have data. Wherever you are, wherever you're starting, you've got data, right? And so we start with a schema, which allows you to describe what are the key parts of your data. This isn't a comprehensive schema, right? Neo4j is schemaless, but usually you have some subset of things that you want to render on your nodes, and those are the things that you need to capture in your schema as far as Tom Sawyer Perspectives is concerned. You have integrators, which lets us connect, as I said, to a whole variety of different data sources on the back end, or you can access directly at the API level, plug into plain old Java objects, plug into the data model that's already running for the rest of your web application, and move on to creating some archetypal templates for what does something look like. So here's an offense type template. It's got an icon associated with it, and we're going to drive the image for that offense type off of a particular set of attributes on the data so that it all remains data driven, right? So here we have an incident, this is the icon actually for an assault. But if we zoom in here, we can see that not every incident looks like an assault, right? But fundamentally, they do share an archetypal description, which you can capture and then apply broadly based on your data to a whole variety of stuff in whatever way you want, right? And similarly, we've got persons, incidents, and descriptors for edges, as well as connectors and labels on nodes, drawing templates. And then here's the really fun part. I want to turn my data, which is incidents and people and associations between those incidents and people, into a drawing. Now, I could create some huge code base to do that associates one drawing view with another drawing view, that associates it back to the drawing, that associates it to the table, that associates it to the tree, that associates it to the geographic map. Or, I could say for every incident, I want to add a node that looks like an incident, right? And for every person, assuming that there's an incident that they're associated with, I want to add a node for that person. And for every relationship, as long as the person and the incident that it's connecting both exist in the drawing, I want to add an edge, right? And so in this very simple, intuitive way, you can stand up a real working visualization component that's going to give you the capability to see and understand your data very, very rapidly and very maintainably and with essentially no coding. All right, so here we're viewing this whole network out here. And these are about 1,000 incidents and about 1,300 people. And maybe we want to run a K-core analysis. If there are data scientists out here, you know what that is. If you are not a data scientist, basically we're finding what type of stuff is heavily involved in other stuff in the network. Very, very abstract level, that's what's happening. And so we run this K-core analysis, and now we can zoom in on a cluster here. And we can see, oh man, some of these individuals got pretty big. They have a high coreness value, right? So they're very central. They're part of a strong clique. We can zoom out, and now stuff is overlapping with other stuff. So maybe instead of just seeing an ordinary symmetric layout, we want to see this with a circular layout. So a circular layout is going to find all of the natural clusters within the network. It's going to display those natural clusters as circles, with nodes that are on the periphery of the natural clusters on the outside, and nodes that are strongly associated with the cluster on the inside. And you can see that the structure of the graph that we get is that we have these circular groups here that are heavily connected within themselves and are only very loosely connected to their neighbors, right? And that's not an accident. That is because we are actually running graph analytics on this ahead of time. Right, and we can change the way it works. So, here, if we've got a coreness value greater than or equal to 1, we're going to display it. But maybe, we're only interested in people who are, heavily involved in crimes. So we want to change the coreness value to 4 and filter that down. And now our network has changed. And we can update our layout to see what are my new clusters among the, heavily criminal crowd, and what do they look like. And I can come down and I can see a result. So, we've got this Courtney Battle person, right? So Courtney Battle has a coreness value of 19. We can see some details of Courtney down here. We can see, we mouse over in the drawing, this bad dude, right, in our tooltip. And, this is great. And this is very much a raw representation of our data. But it probably doesn't get us everything we want to see. So maybe we want to just see what is the social network of criminals, right? If two people work together on a particular crime, they're associated with one another. So let's form a social network. And here is our social network of criminals. And we can, do an orthogonal layout, pack them in nice and tight around each other. All right, so now we have a tight packed schematic of all of the individuals. Here you can see that there are no overlaps between any objects. Edges can intersect each other, of course. I mean, there are some graphs where it is impossible to avoid that. But no edge will ever overlap a node. No node will ever overlap a node. No label will ever overlap a node. And we're interested in, again, if you're a data scientist or some type of investigator, you may be familiar with social networking algorithms. And in this case, we'll just run some between centralities. So these are all, so we have over 30 graph analytic algorithms that we run out of the box. And here we go. So now we've resized all of these folks in association with their centrality measure. And let's update that layout. And now we can see, again, in this very nice, very clean, very compact way, who's interesting to me in terms of my centrality. And who's got, better watch out for this guy, right? So you can work in that way. You can filter by, you can view geographic incidents. So I can go in and I can find, okay, so, here's Courtney. Let's find out about where this car prowl occurred. So I'm going to click on it in this drawing view. We're going to zoom over to it in the map. All right, so here it is. I don't know if you can see that on the projector, but there's a highlight there. It's selected. It's in a cluster of 9 incidents that all occurred in this particular area. And maybe we're interested in filtering by timeline instead. So here, we can squeeze this in, say I'm only interested in a particular time period. And nodes are going to start disappearing. We'll pop out, see how that changes our network of incidents. Again, do a layout so that it gets nice and tight. All right, and so we can also associate this with charts. So incidents by type. We can break down offenses by type. So here are all the types. Here are all the assaults that occurred, broken down. So disturbances. We can parametrically control what we want to have displayed in each view. I guess some of these are all uniform. We can see the ages of people who are involved in crimes. We can select down here. I want to look at, let's see, who's interested. Let's look at Dante Mercado. And we've gone and found him here. We don't have a picture for him. We can see that he's associated with property crimes. They've occurred at this time. We can see who his associates are in this other view, right? So Dante works with, let's see, Rusty and Eloy, right? And we can see the social network analysis results that we ran, right? That are down here, and we can see that Kenny is on top. And now that we've filtered down our data set based on time, we want to see, okay, so who are the movers and shakers in the criminal network during this period of a couple months? And so let's refresh our social network results, and we're going to run between this again. And you can see that the results actually changed pretty dramatically. So if you're interested in very specific data, you want to dynamically decide what that data is, and then be able to run your analytics on just the subset of the data that's interesting to you, right? And we can update that again. So with that, that's sort of going to be my part of the presentation. We've got Craig and Greg down here who are going to show you a real application that's using Neo4j on the back end, using Tom Sawyer perspectives to create this layer of data interaction that lets you have huge data in the back, turn it into a small subset of data, dynamically filter it down so that it's really the part that's very most interesting to you, and then run analytics based on every way you can slice it, see how it's associated with charts, see how it's associated with maps, see how things are associated with other things in a rule-based way that requires almost no code to stand up, and that lets you stay close to your data and understand what you need to understand at all times. Okay? Yes?
Well, my name is Craig Lamont. I'm the president and founder of TurningPointCSI, and it doesn't stand for Crime Scene Investigation. Actually, it stands for Consulting Software Incorporated. We were formed on the basis that if we gave the right software to end users, they could be their own consultants. So while Greg is working on this, to get to what really started the company, happened in about 1992. I was the executive director for advanced prototypes at Bell Atlantic. The CIO, Ralph Shagenda, who later on became CIO of General Motors, brought me into his office on one-on-one and said, Craig, I've got 1,600 applications running on 5,000 servers. We know that we're spending too much money. The systems are failing. We have replicates. We have 12 different product databases. I need something that is going to allow us to make decisions on what we're going to keep, what we're going to get rid of, what we should modify, what we should try to salvage at least parts of. And he said, by the way, I want that in about 1 month. And I walked out of that meeting saying, I better update my resume, because I don't think I was going to be able to do it. But we tried. We tried using MicroStation and Oracle at the time, and while we had a small success, it wasn't anywhere near what if we had Tom Sawyer perspectives today and Neo4j, we could have done. So what Greg is going to show you is an interesting study on responding to a customer problem. Customer's problem was they were spending $400 million, which, by the way, they decided to spend on what we call Generation 4 of decision vision. What we're going to show you is Generation 5. So here's the problem. And I'm using the real names. Mike had the information about the data centers. Kathy had the information about the ESX cluster groups. Chris and Lyle had the information about the VMware virtual clusters. The storage group had the storage information. The network group had the network information. There was about, I would have to say, about 12 different players. And they tried to get together to try to be able to figure out, if we make a change here, how does that affect everything else? So they quickly realized they weren't going to be able to do it. Just a single change, they would like go away for a week and come back and we say, well, we think it's this. Well, that wasn't going to cut it. So the chief architect of a major power utility company, which is our client, said, well, we don't have anything in-house. We have all the, the big monitoring and asset management applications. You probably know them as well as I do. And they're not going to cut it for us. And we already know that if we go out for an RFI, that will take 2 weeks. If we go out for an RFP, that will take a month. We have to take 2 weeks to evaluate the RFP. And then another 2 weeks to evaluate it. Then another 2 weeks to negotiate a price. Then get the product in, train people on it, and get it to work. And then you can actually start implementing something. Well, what we're going to show you is something that we delivered in three months. Frankly, we got it done before they could have even gotten the product in-house. So our niche, what we do, and what Tom Sawyer Perspectives really gives us a great advantage on, and also Neo4j, is that we can go through iterative development extremely quickly. Because, as I think we all know, not all the clients know exactly what they want. So there were a lot of redesign sessions, redesign and redesign. And because of Neo, for example, we didn't have to scrap the entire data model. In fact, there was a model, it was schemaless. And that was a real advantage for us. So I can see we're having a little problems here. It's a good thing I memorized the presentation anyway, because it's mostly a history lesson. And the history lesson is, we want you to go away with 3 things. First and foremost, if you are going to realize that you do not have a solution that you can buy commercially in the marketplace, you have only one choice. Either scrap the project and hope you can live without it. Actually, two choices. Or you can look for something that's going to give you a point solution extremely fast that, by the way, you can reuse in other places. And that's what we're doing now with this client, who realizes that, hey, we can do this with this, and we can do that with that. So probably the best way to explain this is the 3 things we want you to go away with is, first of all, Neo4j has been an absolute godsend to us. We can quickly take 12 different data sources, put them together, and in fact, I wasn't sure I even want to talk about this. So we found out while we're doing this that there was a parallel effort being done by another company to put together even a subset of this data, and they were charging the client 7 figures. And I was saying, boy, I must be a pretty bad businessman, because I would have loved to have bid that out and got that into the company. We did it for less than 5% of what they charged. 5%. And we did it, instead of doing it in a year, we did it in about 3 months. Actually, I think Greg, Greg, our principal partner and VP of development, I was the gopher. I was going and getting all the data, giving it to him. He was putting it into Neo, and we had something done in about 7 weeks. That took another team of multiple people a year to do, and for a lot more money. We were tested, by the way. We brought it over to this project manager, and she said, I don't believe you could have done it. So I'm going to look through my spreadsheet. I'm going to say, what about device, and I might actually be using one of the devices that you're using, Greg, 1604. And so Greg types in 1604, bam, comes up. All the information about that device. So long story short, I'm just really kind of the setup man. What Greg is going to do is show you what we've been able to put together. It would be a huge mistake just to think it's just an infrastructure model. It is a decision support system. It is an intelligence-based system. So with that, Greg?
We're ready. All right.
And I did it without a single PowerPoint slide.
All right, well, appreciate that. What I'm going to do is walk through a very quick use case of how we were able to combine Neo4j and Tom Sawyer Perspectives to help this client be successful in the project. So as Craig was mentioning, this is a big enterprise project. What they were doing was basically building an entire new infrastructure network, a whole new network. So they needed to be able to move the devices off the old network onto the new network, or in some instances, just migrate an application off of the old device onto the new device on the new network. But before they could move anything, they need to understand what's the impact of me moving this. What's the impact? Who do I affect? What applications are going to go down if I pull this thing off of the old network, or if I pull the application down and migrate it over? So they didn't really have a very good view into that. As Craig mentioned, there's a bunch of different data stores. They have their physical asset information in their asset management system, their application information in their inventory management system, and application interfaces, well, that was good luck. That was numerous spreadsheets on people's desktops, et cetera. So we're able to go in and combine all that and create this one single view so they could just kind of crawl through whatever they're interested in. They can understand the impact. When we say the impact, really, in Neo4j parlance, what we're talking about are basically all the edges to that node. What are all the edges to that node? What does it affect? So that's what we want to see, and that's what we want to make sure that we understand. And that moves into our project planning process. So that's really what they're kind of using it for, was to help with those migration plans. All right, so let's take a simple example. All right, in this case, we know that we are going to move this particular device in a couple weeks. So we want to start planning for it. Now, this is actual data, so I've anonymized it, so it's just device number, department number, et cetera. But it is real data. All right, so we know it's a physical server because basically we can use those icons that Josh was talking about to represent different nodes. I'm going to expand that. We also have all of our attributes over here. So this is all the data that's in Neo4j. So we can capture, however much data you have available, we can capture that and add that to these nodes. So you have whatever you need at your fingertips. All right, so off the bat, we see it's an IBM machine. It's in cabinet BR35. We could expand that. There's only one server in there right now. We can expand the BR35 cabinet, figure out where it's physically located, what data center it's in, what room it's in, et cetera. And we've got a couple other physical servers that are tied to it. Basically, these are just management servers. If you were needed to do any service to this server, you'd log in through these servers. What we're interested in, though, is this cluster here. So it basically looks like it is a host for some virtual instances that are being managed by this virtual cluster. So let's drill down another level, see what virtual instances are running on this cluster that's being hosted by this server that we want to move. All right, so there's only a handful of virtual instances. This is actually pretty good because this client, they only have a couple cluster managers, and most of them have hundreds of virtual instances that are running. So those are a lot more complicated migration scenarios. So right now we're feeling pretty confident this is going to be a pretty easy move. All right, but we want to drill down a little bit more and understand what's on these servers, because that's really where we're starting to affect people, are the applications that are running on these virtual instances, right? So let's drill into one of these instances and figure out what's going on here. Now, what's happening on the background is we're actually sending parameterized queries to Cypher. So we're able to take full advantage of all the native capabilities within Cypher from the front end, from Tom Sawyer perspectives. All right, so we can see immediately we've got the AIX operating system. So this is an IBM box. And it's used by this department, Department 4. Now we can also drill into this department and we can see how many people are involved in this department. Is it 100 people across 5 different states that are in this department? Or is it 5 people in one state that are in this department? Basically, we're saying this department uses this machine, which in essence is saying that they're using this software. This little Star Trek badge is the icon that we're using for applications. So basically, this is the department that we might be affecting. Now, those are 2 totally different change management scenarios, organizational change management risk profiles. If you're changing something that affects somebody in 100 or 100 people in 5 offices, or 5 people in 1 office. So immediately, we're giving you some more information about how you need to plan for this migration. Now, we see there's 1 application running on this virtual instance. So again, we're feeling fairly confident. Doesn't seem like it's a very overly used instance. But we know we can't just pull an application out of usage, out of production, because this usually has some application interfaces to it, right? So let's see what is communicating with this CIS system, this customer information system. So we're just drilling in 1 more level to get a little bit more detail to help us plan. Okay, well, our diagram just blew up, right? So we've got a lot of application interfaces, a lot of other applications that are talking to that. Tell you what, I'm going to change the view to more of a hierarchical view so we can kind of see what's going on. So we've got our CIS ecosystem, basically. If we scroll in, these are all the applications that have an application interface to it. We can see it is also installed on a bunch of other virtual instances. In this case, those blue lines basically show that it's a non-production environment. The black line shows it's a production environment. If we scroll back over, all 6 of those instances that we were looking at that are being managed by this cluster, that are being hosted by the server we want to move, all of them have CRS installed on it. So within a couple clicks, we see that we've got this highly integrated environment. So our planning process is probably going to change a little bit. We need to now take this into account on how we're going to migrate this one server. It looked like it was going to be fairly simple and straightforward. It's heavily integrated. It's kind of the heartbeat of that organization. It's really kind of their billing engine. So it's going to be a little bit more complicated than we thought. But with just a couple clicks, we're able to get all that information from a visual perspective. Now, sometimes that's not enough. So we've got reports down below. So these are the different tabs. Tom Sawyer Perspectives allows you to do this tabular information. So basically, we can load up some data, and you can think of these as canned reports. So we've worked with the client, figure out what do you want to see while you're looking at these diagrams. So this is the information that is important to them. And we can run these, and similar to what we're doing when we're exploding those nodes, we're sending that parameterized queries back to Cypher and returning it. Now, we can also constrain these by the view, it's in the drawing view here. By that, I mean we're filtering it. So what's being returned down below only applies to what's being shown above. So you've got your tabular information, and it's tied to your graphical information. We can export those to Excel or export the graph as a picture. And now you can include this information in your project documentation. Similarly, we also have the ability to write data back to the database. We have the icons here. So if we know that, for example, there's another department that uses this that we know about, we can actually add the node, add the relationship, fill in the attributes, and save that to the database. So we can write data to the database as well. All right. We also have charts and graphs that were just recently released in one of the later releases of Tom Sawyer Perspectives. Now, what's interesting here is this graph and this chart capability was not part of our original ask. But when we were demonstrating this to our client, we had a gentleman in the demonstration who said, hey, this is great. This is good information. It would be extremely helpful for me if I could add some financial information. In this case, pretty simple. I just want to know my yearly O&M costs and when those O&M costs drop off. And that's what I typically look at. So we were able to respond to that very quickly because all we're doing is adding new attributes to nodes that already exist. So again, we mentioned that Neo4j is schemaless. We don't have to go back and rework the whole data model. We can add data pretty quickly and pretty easily. And what happens is, find out is what I like to refer to as our sphere of influence. Our sphere of influence grows. What do I mean by that? Our sphere of influence started off as show me all the devices, show me all the applications that are on there, show me the application interfaces. So just the core information that we're looking at. Somebody comes up and says, hey, that's great. If you could layer on this little bit more information, it's extremely useful to me. So layer on that financial information. Then somebody else comes along and says, hey, you're starting to grow this out. Now you have this data. Could you add projects and show me how technology or how projects affect which technologies, interdependencies between projects? Can you show me that? So now your sphere of influence starts to grow. And then people say, what about my business processes? Can I map my business processes to technologies so I can determine how well my IT is performing for my business? So now you're moving out of this very typical network, IT analysis into this more business-focused analysis, portfolio analysis, and enterprise analysis, and into those more interesting use cases and where you're starting to stretch the graph information a bit. Not looking at just direct connections like a network map. And that's where the interesting thing starts to kind of shine and start to come up, and those interesting use cases start to pop up. Now we also have the GIS capabilities, which I think we're showing with the map here. We've kind of located all of our data centers. So you can come at the data from this high level, show me the data center, and I can drill into there and I can see all the computers that are there. I can see all the racks, where all the computers are racked, et cetera. Or we can come in at that low level. So with the combination of Neo4j and the Tom Sawyer Perspectives, it allows us to quickly respond to those requests, add some financial information, add these business processes. We could do that without having to scrap our entire data model and starting over and putting the relational database in third normal form and all that fun stuff. So we can respond and we can create these solutions for our clients much quicker than traditional methods. So that's how we're using the products and combining the products, and it's giving us a platform where we can, again, expand into other areas of this client to help them understand their enterprise, because really all we're doing in the end is we're mapping the relationships in your enterprise and giving you that insight into your data. Any questions? Did the map ever come up? Looks like it's choking. Okay.
How did you do the initial discovery?
Good question.
And how did you, I mean, you said 1,600 different applications and like multiple different connections, the relationships between them,
right,
and the configuration of each and every server, or the people who maintain the cost and everything. How did you do that initial discovery? Unfortunately
for me, it was all manual for this one because it was in so many different systems. A lot of it was spreadsheet, and they don't have systems that show these relationships. You know, they have the system that shows here's this physical server, and here's the stuff that's installed on it, here's the operating system that's running, etc. But it doesn't really necessarily show that this this server has these applications on it, and these departments rely on these applications. So I had to manually build a lot of that. What we're looking at with the client now is to start doing some integration. Now that all those nodes are known in the database, can we do some automated integrations to these source systems to add those automatically? But unfortunately, for this first go-around, it was manual. I was doing a lot of spreadsheets and using load CSV. You were able to do all that
manual discovery in 2 weeks?
It actually took about a month.
Okay.
And so a lot of out of that 3 months, a month of it was basically discovery, getting all the spreadsheets, putting in a format that I could use for load CSV, creating the relationships and loading it up. But the load CSV was kind of a godsend. It's actually fairly simple to use. Mm-hmm. So we were able to just kind of create a few spreadsheets and then load them into the CSV thing. But yeah, it was me, a lot of late nights and a lot of Excel.
So can't you just connect to like some of the data source, like CMDB type of a data sources that every other organization that they have, and then bring that data from there? Yeah. Is there a way in this application to connect to those data sources?
Well, basically it's you'll be connecting from the Neo4j side. So you can use whatever technologies that can connect to Neo4j, so it's some Java. So what we were looking at with the client was Informatica was their ETL tool of choice, so Power Builder. So looking to see how we can extract with Power Builder, do whatever transformation it needs, and then call some Java program that could load that into our database. So we're still kind of working that out with the client on how best to do some of those integrations.
So thank you very much. Unfortunately, we have to cut it short here because we run a bit of overtime, but you can surely visit them at their booth over there in the exhibition area and ask further questions. Thank you.
Great job.